Good morning. This is Ms. Billerbeck, and we're going to talk about Section 1.4, Least Common Multiple, abbreviated LCM. So the least common multiple, LCM, of a group of numbers is the smallest positive integer, which is divisible by all the numbers in the group. So it's the same thing as the least common denominator, LCD, that you've been finding with fractions. So let's do an example. So we want to find the least common denominator. Let's see if that works. Of 40 and 50 and 150. All right, so we have 40. We want to break that one down. So that's 2, 20, take a 2 out, 10, take another 2 out, and we have 5. So 40 is 2 cubed times 5 as our prime factorization and exponential notation. So 150, we take a 2 out because it ends in 0, and that gives us 75. 7 plus 5 is 12. That means it's divisible by 3, so we can take a 3 out. So there are 2 3s and 7, carry a 1, and 5 3s and 15. And 2 plus 5 is 7, so it's no longer divisible by 3, but it is divisible by 5 because it ends in 5, and we have 5 times 5. So the prime factorization of 150 then is 2 times 3 times 5 squared. So now when we want to find the least common multiple, let me try that again. So the least common multiple, what we're going to do is write this out. So we have 40, and we're going to make lots of room. So 2 times 2 times 2. This one has a 3, so we're going to leave a little space for a 3. And then we have a 5 over here and a second 5 over there. So let's write 150 down now. So 150 has 1, 2, and then it has a 3, and then a 5 and a 5. All right, so we note which ones are duplicated. Okay, so we have some duplicates there. Now, if we write what we see on the bottom, after we duplicate, we have 2 times 2 times 2 times 3 times 5 times 5. All right, so that is 2 times 2 times 2 is 8. So we have 8 right here. Times 3 times 5 is 15, or let's do 8 times 3. And then 5 times 5 we know is 25. Okay, so 8 times 3 is 24. And then times 25. So let's see what our answer is for the least common multiple. So 5 times 4 is 20, carry a 2. 5 times 2 is 10, plus 2 is 12. Leave a space here. 2 times 4 is 8. 2 times 2 is 4. We add this up. We have 0, 10, carry 1, and 6. So 600 is the least common multiple of 40 and 150. Can you think of any smaller number that they would both go into? That would be both divisible by 40 and 150. All right, so another way we could think of this is we could also think of this as the greatest common factor, because we had just discovered that 2 times 5 is 10, which would be the GCF is 2 times 5. So the GCF is 10, but this one is the least common multiple. Okay, so what we could say is, what is 2 times 2? Well, that's 4. 4 times 3 is 12. 12 times 5 is 60. So we could say, let's see, ran out of boards. So we could say that the least common multiple equals the greatest common factor times what's left. Okay, so that's one way we could look at it. All right. We can also look at, well, if we looked at 40, this is another way. So let's erase this way we did it. Keep the prime factorization up there. Okay, so another way you might have seen it done is, what are the multiples? We learned multiples. So what are those multiples? We have 40, 80, 3 is 120, 4 is 160, 5 is 200, 6 is 240, then we have 7, 280, and let's see, I'm going to erase this. 8 is 320, 9 is 360, 10 is 400, 11 is 440, and 12 is 480, 13 is 520, 14 is 560, and then 16 is 600. Okay, so now let's look at 150. Well, I guess we don't want those colons there. Okay, so 150, the next multiple is 300 when we multiply it by 2. When we multiply it by 3, it's 450. When we multiply it by 4, it's 600. All right, so when we look at it this way, there is no 150, it's 160. 300, it's just right around 300. 450, no 450. So it's 600. So that's the least common multiple. So that's the other way you can approach this kind of problem. All right, so let's look at least common multiple of 34 and 57. So we have 34, we take a 2 out because it's even, and that gives us 17. 17th prime, we're done. 57, it's not even, so 2 doesn't go into it. So 5 plus 7 is 12, so that means this is divisible by 3. When we divide it by 3, we get 1, 9. Okay, so because there's 9 3s and 27. So when we look at, well, what is the least common multiple? So we have 34, and that equals 2 times 17. 57 equals 3 times 19. There is no overlap. So the least common multiple is going to be 2 times 3 times 17 times 19. So we have 6 times 17 times 19. Okay, 6 times 7, that's 42. Carry a 4, which gives you 102 times 19. Okay, so double checking, yeah. All right, so at this point, let's just do a regular multiplication in a column. So 9 times 2 is 18, carry a 1, 9 times 0 is 0, plus 1 is 1, 9 times 1 is 9. Leave a space, 1 times 2 is 2, 1 times 0 is 0, 1 times 1 is 1, and we add it together. So for this one, we get a very big number for the least common multiple. Okay, do they have a greatest common factor? Okay, we didn't see one, but what didn't we write down? We didn't write down times 1. So their greatest common factor is 1. Least common multiple is this huge number. All right, so let's find the least common multiple of 54, 84, and 110. So we have 54. We take out 2 because it's even. So that gives us 27. That's not even, but 2 plus 7 is 9. That's divisible by 3. So when we divide that by 3, we get 9. 9 is divisible by 3, and we have 3. So 54 is 2 times 3 to the third. 84 is even, so we can take a 2 out. We get 42. 42 is even, and we take another 2 out. That gives us 21. 2 plus 1 is 3, so that is divisible by 3, and we get a 7. So 84 then is 2 squared times 3 times 7 when we prime factorize in exponential notation. So 110, let's take a look at that. It's even, so let's take a 2 out, and we have 55. 5 plus 5 is 10. 10 is not divisible by 3. It's not even. The next prime number is 5, and it ends in 5, so it is divisible by 5. So that gives it 11. So we have 2 times 5 times 11. So now let's write our numbers. So we have 2, and this one has 2 2s, so we want to leave a space, times 3 times 3 times 3. 84 then equals 2 times 2 times 3 times, oh, there's a 5 there, so we want to make sure that we leave some space there, and we have a 7. Oops, I didn't leave enough space. 7. Okay, so then we have 110. 110 is 2 times, and then we have a 5 times an 11. So let's see if we have anything in common. Oh, we do. Okay, so they all have a 2. So this is our greatest common factor, that 2. So now we can write everything down. 2 times 2 times 3 times 3 times 3 times 5 times 7 times 11. And whatever that is our least common multiple. So 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. And 36 times 3, let's do that one quickly. Actually, let's do 36 times 15. Okay, so we have 30, and then that's 18. Keep a space there, and we have that. So we have 0. That's 14, 540. So we did this, we did this, And we did this. Now let's multiply by 77. Okay, so 77 is our next one we're multiplying. So 7 times 0 is 0. 7 times 4 is 28. 7 times 5 is 35, plus 2 is 37. Leave a space. 7 times, oh, it's the same thing. So we just write the same thing because it's 7. Okay, there we go. So we add them up. We have a whopper of a least common multiple here. So we end up with 15, 11. Oh my goodness, look at this. 41,580 is our least common multiple. Okay, I like the greatest common factor on that one a lot better, too. So here is our least common multiple. So that was not easy. All right, so let's go to a real life problem. So we have, the diagram shows a gear system in which the numbers of teeth on the big and the small gears are 20 and 16 respectively. Respectively means that the first gear, the big gear, which is mentioned first, has 20 teeth. The small gear has 16 teeth. So that's what that word respectively means. The tooth X on the big gear and the tooth Y on the small gear are engaged at the start. So what we want to do is find the number of tooth contacts before X and Y engaged next. And then how many revolutions will each gear make? All right, so here's our diagram. So we want to get the factoring tree for 16. And that's even, so we can take a 2 out, we get 8, that's even, we have another 2 out, that's 4, and that's 2 and 2. So this is 2 to the 4th in exponential notation. 2 times 2 times 2 times 2. 20 then is, we remove a 2 out, we have 10, take another 2 out, we have 5. So this is 2 squared times 5. So now let's write these one above the other and see what we have. So 2 times 2 times 2 times 2, and 20 is 2 times 2 times 5. So when we look at the least common multiple, we see we have 2 times 2, so our greatest common factor, just for, so we know, is 4, which is 2 times 2. So we simplify this by having 2 times 2 times 2 times 2 times 5. So all this is 16 times 5, which is 80. So it's going to take 80 revolution, or 80 engagements before they match, X and Y match up again. So for the small wheel to reach 80, that'd be 16 teeth times 5 revolutions. Okay, for it to equal 80 for the large tooth, that's 20 teeth times 4 revolutions. So that's how to figure out how many revolutions before X and Y are going to meet again. All right, so that's it for this section. You have a lovely day.